Or I'll say, hey, Jack, turn me off. That's the kids love that. Okay. All right, here we go. Number 1A. What are the coordinates of vector AB? We're going from A to B. Look at the points. From A to B. What would be your coordinates? -2, 3, 4. There are the coordinates of the vector from A to B. What does the notation in letter B mean? Magnitude. And to find the magnitude, we just square that one, square that one, square that one, and add them up. So that's going to give me the square root of 29. Boys and girls, you've done that a zillion times. Midpoint. What's the midpoint? Well, of A and B, we're going to average. So what do we get for X? 0. 1 plus -1 is 0. Divided by 2 is 0. What do we get for B? Or Y, I mean. 7 halves. And 5. To find midpoint, we simply add the x's divided by 2, add the y's divided by 2, add the z's divided by 2. Easy, easy, easy. D. Now we're using the vectors and we're going to do the dot product. So what's V dot U going to be? How do we do the dot product again?
Multiply x's.
Multiply x's, so that would be -4. Multiply y's, that would be 4. And multiply z's, that would be 0. So our dot product came out to be 0. That means that vectors V and U are orthogonal. Perfect. The parametric equations. When you write the equations of a line using vectors, you start with this format. This is how you're going to get the parametric equations, right?
Yeah.
What goes in the first parentheses?
One of the points.
One of the points. I'm doing A, B, so I'll just use 1, 2, 3. What goes in the second one?
The distance between them.
The directed distance, the vector coordinates, right? Now you've already figured that out. You could do it again, but you already did it. The vector from A to B is -2, 3, 4. Now that is not the answer though. That is the equation of the line. But it isn't the parametric equations of the line. So what do we need to do to get the parametric equations? Separate it. So x equals 1 minus 2t, y equals 2 plus 3t, and z equals 3 plus 4t. Nia, why's your hand up?
Why did you use 1, 2, 3 instead of? Oh, 8. Sorry.
Okay, now I'm doing F. It says find point C so that vector AC equals vector V. Now, here's vector AC. I need that to equal vector V. And vector V has coordinates -1, 2, -3. I need these two vectors to be equal. So whatever this vector does, I need it to back up 1, go up 2, and go down 3 in the z direction, right? So I need it to do. And I know that it starts at the point 1, 2, 3. So if it has to start at the point 1, 2, 3 and behave like this, this is a vector, this is a movement. So if it's going to start here and move this way, where's it got to end? 0, 4, 0. Kids,
Oh, you said.
if you start at 1 and you back up 1, where are you? 0. If you start at 2 and go forward 2, where are you? 4. If you start at 3 and back up 3, where are you? 0. Remember, a vector is a movement. It tells you how you're moving. All right, that part's done. All right, now we're going to go backwards through number 4, so we're going to start with number D. Now, try to understand here the way I have this set up, because this is exactly how your test will be set up. See these little numbers over here to the side, the 1, 2, 5, 6, 8, 9? Those correspond with the typed things. So when it says 1, in that answer blank, you will put the eccentricity. And where it says 2, you will put the vertex or the vertices, depending on your figure and so on. Got it? Okay. Now, this will be, your test will look just like this. You're going to have all this empty space. Remember, this is 2 separate pages. So on this page, there's only 2 problems. You have all that space. But I'm only grading those blanks right there. So you'll have this space to clean up the equation, because that's how you're going to have to start, isn't it? You're going to clean up that equation. This is part 4, letter D. We're going to clean up this equation. So here we go. We're going to take out a 16. What is that, 8? Here, there's nothing to take out, so we're good. And I'll move my 249 to the other side. Okay? So here we go. We've done this a lot. We're going to complete the square. What goes here? 16, and that means 256 over here.
Yes.
And this is a 9, which is just a 9. So we have another magnificently rigged problem, because all that just works out to be 16.
Wow.
So now we'll divide. And what do we have? What shape? I heard a hyperbola and I heard an ellipse. It's definitely an ellipse.
It's plus.
There's a plus, that rules out hyperbola. There's 2 squareds, that rules out parabola, right?
And it's completely straight.
And they're not the same denominator, so that rules out circle. This is an ellipse. So let's start filling in what we can about the ellipse. Where's its center? Negative 4, 3. So we're going to write that in the blank that says center. You're going to write negative 4, 3. I am not grading your picture. Okay? Your picture is yours. You don't even need to draw a picture if you don't want to. Where are my vertices? Well, the 1 tells me to do what?
Go left,
Go left and right 1. So that would be negative 5, 3 and negative 3, 3.
So you,
What does the 16 tell me to do?
up and down 4.
Up and down 4. So that would put me at negative 4, 7 and negative 4, negative 1. Those are the 4 vertex points. So in the blank called vertices, you're going to have 4 points listed there. 1, 2, 3, 4. How long is my major axis? I think that's one of my questions, yeah. How long is my major axis? 8. How long is the minor axis? 2. We should have missed that. Where are my foci? Well, they're going to be here on the major axis somewhere. In order to figure out where they are, I need the center to focus distance, right?
So it's
How do I find the distance from the center to the focus? Subtract my denominators and take the square root. So that distance is root 15. So I'm going to start here at the center, and I'm going to go up and down root 15. So what will those points be? -4, comma, 3 plus root 15, and 3 minus root 15. Remember, we operate from the center. What is my eccentricity? Distance from center to focus, which is root 15, over distance from center to vertex, which was 4. Have I filled in all the blanks?
Yeah.
Okay, so I'm ready for C. All right, one thing about videoing, I can only use this board, so I need to erase this. Everybody good with that? All right, here it goes. Ready for problem C now, 4C. So we have x squared plus 2y minus 8x plus 18 equals 0. What is this? A parabola. And you can tell it's a parabola, gang, because why? There's only one squared term. We're going to complete the square. Do you remember in the problem I just erased? I had an x squared quantity on this side, I had a y squared quantity on this side, and I moved that number over. That's what I do with stuff that I'm not completing the square on. If I'm not completing the square on it, it gets moved. So everything gets moved except the x's. Everything else is going to the other side because this is the only square that you're completing. I am a tricky devil. I did this on purpose. You got to pay attention. These aren't the two that go together, are they? No. Pay attention. So now we're going to complete the square. So what gets added here? 16. So we have x minus 4 squared equals -2y minus 2. So x minus 4 squared equals -2 y plus 1.
That's true.
Where's my vertex?
4, -1.
4, -1, yep. Which way do I open? Remember, you're filling in the blanks. Your vertex is at 4, -1. I hear somebody say I open down. I agree wholeheartedly. How do we know we open down?
X is squared and the number is...
X is squared and it's negative. Right? This is your axis of symmetry. I can't remember. Is that one of the things I have to fill in? It's not. I'm going to go ahead and write it anyway. X equals 4. Here's my focus. If I knew this distance, I would be all set. We call that distance P. How do we find P? This guy right here is always 4P, right? So if 4P is 2, P is a half. It doesn't matter, I'm going down, right? I don't care, it doesn't matter to me. It's a distance, it shouldn't be negative, but it doesn't matter. It tells me I'm going down. So I'm going down a half. So what will be the coordinates of my focus? 4, comma, -1.5. Write it as a decimal, write it as a mixed number, write it as a fraction, I don't care. -1.5. If you came down a half to get your focus, you're going to go up a half to get your directrix, which is a line, not a point, it's a line, and it will be the line where y equals -1/2, because you went up a half. What else do I need to know? Eccentricity. It's a parabola. So its eccentricity is
4.
1. All parabolas have an eccentricity of 1. I got my I need the endpoints of the latus rectum. Here's the latus rectum, right? How wide is it? What's the length of the whole thing? 2. If it's 2 units all the way across, then we're going to start right here and do what? Go back and forth 1.
How do you know this length?
This number is always the length of the latus rectum. Now, if I start here and I go back and forth 1, my endpoints will be 3, comma, negative 1.5, and 5, comma, negative 1.5. I got my directrix, my focus, and that's all I needed. So I'm done with the parabola.
What about your length? That just
The length of the latus rectum isn't listed as a number there, but it is 2. Okay, B. What's going on with B? What are we going to have to do? Complete the square twice. So my x squared plus my 4x, my y squared plus my 8y. Here we go. 4, 16, x plus 2 squared, y minus 4 squared equals 30. What's my center? Negative 2, 4. What's my radius? Square root of 30. And what's my eccentricity? 0. Every circle has an eccentricity of 0. There are no foci, so it's 0. And now number 1, or A. All right, here we go. Let's do some grouping here. All right. I went ahead and grouped my x's and y's together. Got ready to complete the square, so now I'm ready. What completes the square here? 1, but I'm going to add. What completes the square here? 9, but I'm going to add negative 144, I think.
Yeah.
Okay, so I've got 9, x plus 1 squared, minus 16, y minus 3 squared. Did I factor out my negative correctly? Yeah. Equals, another perfectly rigged problem. So when I divide, I get x plus 1 squared over 16, y minus 3 squared over 9 equals 1. Hyperbola. Now in the real world, if you were walking down an alley and you found a hyperbola, it probably wouldn't work out this beautifully. But for your test, I will try to perfectly construct another problem that's beautiful. Where's my center? Negative 1, 3. Now, Obviously, I'm filling in blanks, I'm not drawing a picture, but I'm going to draw a picture because it helps me. So I'm gonna need to build my box. When I draw a hyperbola, I need a rectangle, a box to frame it in. So, what does the 16 tell me? 4 to the side, so 1, 2, 3, 4, 1, 2, 3, 4 this way, 1, 2, 3, 4 this way. And the 9 tells me up and down 3. So I'm gonna go ahead and build my box. And I'm gonna go ahead and put in my diagonals. Now, which way does my hyperbola open?
Sideways.
Sideways, because x comes first. So this big black point right here and this big black point right here are the vertices. Those are the two vertices. If it had opened up and down, my vertices would be here, but they're not. This axis is called my transverse axis, right? It's the important one. So I need you to listen carefully to this. On the paper, it says length of major axis. That is where you're going to put the transverse axis. Major is the most important one. It doesn't have anything to do with length in a hyperbola. It's which one has the vertices. So the transverse axis has a length of 8. The conjugate axis has a length of 6. Now, my foci are in here, and I would know where they were if I knew how far it was from the center to the focus. In this hyperbola, how far is it from the center to the focus? It's the square root of 9 plus 16, which is 5. So I'm going to start right here at the center, and I'm going to go forward 5. Oh, I never labeled my vertices. I'll do that in a minute. So if I go forward 5, this will be 4, 3. And if I go backward 5, negative 6, 3. Those are my foci. Start at the center, go back and forth 5. Now, I never labeled my vertices. I never labeled my vertices. That would be, go back and forth 4. So that would be 3, 3, and negative 5, 3. Your homework is to finish this paper, so you need to finish that problem and do the front side. Can you turn off the video, Max? And